We're going to learn all about Synapse Analytics Spark pools, some interesting findings that I've had recently, and just a basic overview. So we won't get too heavy into like things like Spark and Python, but we'll cover some of the things and I'll give you guys some pointers, kind of optimize some things. So I think I already had a pretty good introduction. Just a couple things to kind of call out here. I do my own consulting, so reach out if you need any help setting up modern data warehouses in Azure or dimensional modeling. I'm always happy to take questions, especially around dimensional modeling and modern data warehouse architectures via email, LinkedIn, Twitter. I do have a YouTube channel that I'm still, at some point, I keep threatening to post stuff up there, but I'm hoping to get there. So feel free to subscribe when and if content ever shows up or not, TBD. Lots of certifications. We don't need to dwell on that. So we're just going to talk a little bit about what Spark is, look at Azure Synapse Spark pools, and then go into a quick demo of setting up a Spark pool. So it's kind of interesting, and we'll talk a little bit about other kind of things in the marketplace like Databricks and should you use this, should you not use this, right? So the first thing though is just to kind of take a step back and understand Spark itself and why not is kind of more important, I think. So I typically look to using Spark when I have at least two, sometimes one of these types of problems, right? I have a lot of volume, and when I say a lot of volume, I mean terabytes, right? Single tables, multiple terabytes, lots of data coming in. So think IoT, sensor data, super high volume, maybe clickstream transactions or like Amazon orders, right? So one of the things I work with a client right now that has about 8 different fulfillment centers, and they get 100, 200, 300,000 orders a day, and they fill those all out, and it's rapidly changing. That kind of talks about the velocity. So how quickly does that data arrive, and also so not only the speed of the arrival, but how often do you need to ingest it and push it through your pipeline, right? So you may not have a ton of data, but you may need it in a near real time, right? So that's where something like Spark Streaming could come into play. Variety is really, in my opinion, it's variety and volume are the two main drivers for using something like Spark. And when I say variety, if it's structured, right, if it's coming from like Postgres or SQL Server or MySQL or any kind of relational database management, usually you can just get away with doing the ETL, with a lightweight orchestration engine, something like Azure Data Factory, perhaps SSIS, and do transformations via T-SQL, right, or stored procedures. But when you have complicated file formats that are semi-structured, maybe things like JSON or custom EDI formats, XML, and they're very large, this is a great environment to do those kind of things in, right? And so one of the things that you think about is you've probably heard a lot about Hadoop and Spark and how do they fit in, how do they relate. So they're really not related. A lot of the same infrastructure that Hadoop would use, Spark uses as well, so that's why they kind of seem joined at the hip. Traditionally, Hadoop was based on a MapReduce paradigm, which basically resulted in everything was a read from disk and then written out 3 times to storage with the assumption that the hardware is going to eventually fail. So that it was a very redundant environment. And the problem with this is that it worked really well, but it was very slow because you can imagine every operation that it had to do, it was basically reading and writing, right, to and from disk, and that was very slow. In Spark, it takes a different path. It takes kind of those operations and kind of works more like SQL Server query engine and builds out kind of a logical plan, and nothing really happens until an action's called or it's told to do it. So it has that laziness, but the other key thing is it's also using memory as opposed to storage, so it makes it a lot faster. So talking more about that architecture behind Spark, there's typically a driver program that'll be kind of your head node in the cluster. That'll have all the management utilities and all the communication. And then you'll have multiple worker nodes. And then within worker nodes, there can be multiple tasks, and we'll talk more about that. And then those worker nodes are where the work actually gets sent to do stuff, and they'll talk to data sources, could be file-based, could be NoSQL, could be SQL sources, and distribute the work out. So what's nice about this architecture is it scales out horizontally. So, if you have, let's say, one really large table, you can read that table all into memory, right? And that might be a single-threaded operation, could be parallel, just depends on the way the driver works. But then once it's in memory, Spark can split that out across all the different nodes and operate on pieces of it at a time. to become more efficient. So that's how it's able to deal with lots of volumes of data. There's more to it than that, but that's the general concept behind it. So it's all based on JVM right now. That's one of the reasons why it can be kind of not as efficient. So they're moving towards more native C++ with some of the Photon stuff. But for now, we'll just assume that everything's JVM based. But basically, you have slots on your executors. Those are basically your threads, right? So your nodes, and then you have threads usually to the number of cores. So if I had a four core box at 4 nodes, I'd have 4 slots in each box here. And then there's like I said, there's the driver, and then the worker breaks those out, and then when units of work come like that, let's say it has to do a group by or an aggregate of some sort, it's going to break those out and assign those tasks to slots, and those tasks will grab the information from the data and process it and return results back, potentially. So I mentioned Spark Streaming, but there's a whole ecosystem around Spark. So you have the core, which is the different APIs, right? So there's R, SQL, Python, Scala, Java, and in Synapse we have actually support for .NET. But then you have this data frame API that kind of sits on top of those. You have a streaming API, you have a machine learning API, and then a graph API. So we're not going to talk, we're really going to focus primarily on Spark, SQL, and data frames at a pretty high level, and primarily be looking at Python and SQL. It turns out that the actual difference between Scala and Python from a code standpoint, there's a major differences, but it looks to the eye. You can kind of be confused as to what your language you're in. So it's one kind of tip that I would say is if you're going through this and you're not super strong with Python and you come across some code that looks like it might be Python, just keep in mind it could be Scala, whereas Java's a little bit more distinctive. So something to keep in mind there. So again, Synapse, if we take a step back, I probably should have a better slide for Synapse. In fact, I think I'll skip this and just go into the overall Synapse story. So what Synapse does, in case you're not familiar, is it brings everything into a single user interface. Everything that you would need to do to integrate data, enrich data, transform it, process it, query it, and even visualize it with things like Power BI, right? And so under the hood, there's a web-based interface that's called Synapse Studio, so we'll take a look at that. There's integration, or basically ADF-like pipelines, right? In fact, it is based on ADF. There's a management interface, there's monitoring, there's security that all kind of underpins this. And then you have different pools, right? So within SQL, we have 2 types of pools. We have a dedicated SQL pool, and we have a serverless SQL pool. And then the Spark pool, which is what we're going to talk about today, is its own kind of serverless. And that's really important to understand. It is serverless. Obviously, nothing's really serverless under the hood, but it's important to understand that it's not like, for example, a dedicated pool where you turn on the Spark cluster and turn it off. It manages it for you, and that can lead to some interesting things. And then just recently a released was this Data Explorer pools, which is based on Azure Data Explorer and the Kusto query language. And that's primarily targeted more at real-time workloads, telemetry, things that you would normally use like Splunk or Elasticache, those types of workloads. And then underpinning all of this is kind of a data lake or Azure Data Lake Gen 2 storage. Now, that's not the only source, but that's kind of one of the main sources where you'll be working with data, especially from the Spark environment. It's not to say that I can't pull data out of any relational database management that has a JDBC driver or dedicated pools or Cosmos DB or other NoSQL solutions. Basically, there's lots of different drivers, but primarily based on pulling data out of files. So with that being said, if there's no questions that are kind of relevant at this point, let's take a look at how we actually work with this in the environment. So I've already pre-created a Synapse environment here, just to give you a quick walkthrough. It's also important to call this out, I think. So now this is just the Azure portal, okay? And within here, you can see I can see my pools in here, so I can see some of the stuff. And if I click, for example, on my Apache Spark pools, I'll see a pool and I can create a new pool from here. In fact, let's just go through and do that. Now, this pool right now, this definition doesn't cost me any money as long as it's not running, right? So it may turn out that I may have, dozens or more of these for specific workloads, and we'll walk through and talk about these settings as we kind of go through the demo. So the first thing to understand is the naming. It's pretty strict on what it takes. So I'll use like SP demo. Let's call it 02 just to make sure. So there's the naming standards. So that's what I have to conform to. I'm not going to talk too much about isolated compute. This is more of a security setting. I'll just leave it disabled. Memory optimized. There used to be a CPU optimized. So one thing people ask is, what's the difference between this and something like Databricks? And there's a lot of differences, but one of the key differences is with Databricks, I have way more options as far as the cluster size and even types of clusters. So to that end, for example, with Databricks, I can create a single node cluster. I can't do that in Spark Pools. Databricks, I can create, CPU optimized, memory optimized, different types of GPUs. I can control the storage, the underlying storage. Here, you have less flexibility with that, but it's still fairly functional. So basically, what you choose here is the size, and we're just going to stick with small, I think. This should be, depending on the size of your data, obviously you might need to go larger, but one thing to note is by default, when you submit a job to the cluster, or if I run a notebook, it's going to monopolize this entire cluster, right? So it's a serverless environment, and if I have a workload running on this, anything else that I want to submit to that is going to queue up unless I do something to control the number of cores available. Okay. Auto scale. So we can enable it or disable it. It just basically says, do you want it to scale out nodes as it goes? Now that takes a little bit of time to do that, so you have to kind of think about that. I'd recommend generally setting it kind of for an optimal size. So in this case, I'm just going to go 3 and 4. But what's interesting here is, let's say I don't even need 3 nodes. Let's say I need 1 node. It's not gonna let me do that. It won't validate because I have to have 3 at minimum, and that's 1 driver and 2 execution nodes. And that's one of the differences between something like Databricks. I can have a single node cluster, right? Dynamic allocation of executors. This basically allows it to be smarter about how many executors it uses. So when we think about those jobs, so let's say I need to read data from a file, and then I need to do a group by and then write the data back out. Roughly, that's going to be the equivalent of 3 different, what we call stages, right? So the reading is one stage, the group by is another stage, potentially, depending on how complex it is, and then the writing out would be another stage. If it needs more memory or more executors for the group by stage, or maybe it needs it for the reading stage, this will allow it to change the number of executors throughout the job lifecycle. It doesn't have anything to do with the cluster size per se, right? It's a configuration. Let's look at some of the other things. So automatic pausing, this is pretty important, especially from a cost management perspective. I'd recommend setting this to 5, because what will happen is your build, as long as this thing is running, and especially if you're working with notebooks, those notebooks don't explicitly time out usually. And so I leave this to a small number to keep things cost manageable, especially in a development environment. The trade-off here, though, is if I need to submit a new job and if the cluster stopped, then it's got to rehydrate that entire environment. My sessions will go away, right? My application context has to start. And I found it's about 2 to 3 minutes to spin up from a dormant state. You have to choose your runtime. For legacy reasons, you might need to go with 2.4. I generally tend to be pretty aggressive about this and always choose the latest version. This is another area where Databricks really has a lot more functionality, so a lot more different versions and options for libraries. Also, you'll notice that once I pick this, all these settings are kind of here, so I don't have control of changing like the Scala version. This is just kind of what I get, right? This can be a good thing because it's probably a little bit more stable. But the bad thing is what if I needed like a new feature of Delta Lake that's in 1.5 or something, right? I'm stuck with this and I can't really work around that. Now, that's not to say that I can't install different modules, right? These are the core underlying runtimes, right? So the programmatic environments. As far as Python modules, you can see here I can upload any of the packages or modules that I want from Python, at the server level, which means it's available to all notebooks and all jobs by default, or I can turn on allow session level packages, and that allows me to import those when I spin up. Now, the interesting thing here is I think there's still a restriction around this where if I choose session level, I can't do both, right? I have to do one or the other. So I'm either doing workspace level packages, or I can do session level, but I can't do both. I think it causes some conflicts. I think they're going to fix that. There's a bunch of other configuration attributes that I can specify, and I can upload a default file for that. We'll walk through that in the when we get back to the demo. But that's pretty much it, right? Once I do all that, it's going to create the cluster, assuming it validates. This is going to give you your cost per hour. Just understand that you're going to be paying for up to 3 or 4 nodes at this burn rate, right? So it's important to understand the pricing. But once I hit create here, I'm not actually paying for anything, right? At this point, it's just metadata that's going to get deployed, right? So let's give that a little bit of time to bake and go back to the demo. So we haven't looked at the studio yet. So at this point, we'll eventually go in here. But one of the primary ways you're going to interact with the Synapse pools is through, or Synapse Spark pools, is through notebooks. You can also submit jobs, and a job can be a jar file or a Python module or script. So there's options there, but generally speaking, a lot of people use notebooks. A couple things to note about that, so the environment here gives me, through the development hub, gives me notebooks. One important thing to realize here is you might think, well, hey, I heard Azure Data Studio supports notebooks, and I can create notebooks for my SQL scripts. Synapse doesn't support that. So these notebooks are Python notebooks, or they're actually Interact notebooks. So if I want to do SQL scripts, I actually have to write them in this SQL script format, basically a traditional SQL file. So that was one thing that kind of confused me, because when I saw the notebooks, I was like, oh, cool, I can write SQL notebooks and run them against my serverless pool, or if it's just PySpark SQL, I can do that, which I can do. Another thing to note here, and these are the 2 primary ones that I would say you should memorize, is I choose over here, I choose the language, and I've chosen the default language to be PySpark, which is Python, but I can override that. And so here I'm explicitly saying, yes, this cell. So a notebook consists of multiple cells. There's 2 types of cells. There's code cells, which is what we're looking at here, and then there's a markdown cell, and I'll show you guys a little bit more about that. It's kind of interesting. A little different than Databricks, not quite as robust, but has some features that Databricks doesn't as well. So this is saying, hey, treat this code, anything below here, as Python. And this is also what's known as a magic command. So it starts with %%. And these are relatively standard. Synapse generally supports most of the magic commands. There's a few that it doesn't support, mainly because they're not relevant. But most of them are now supported. If I wanted to just run a SQL query, I could just change the magic command in another cell and use the %% SQL here. So pretty basic. We'll kind of cover this more. So here's those magics to change the different languages. So if I wanted to use C# or Scala, would be %% Spark. That's the one that people kind of potentially get confused on. But anyway, so those are the ones that you put, and it has to be at the top of the cell. I can't change within a cell. So once I define it for the cell, it's for that entire cell. Okay. Here's some other notebook magics, and there's line level magics, right, which work at a line level, and then there's cell level magics, which work at the cell level. So things like list the currently available magic functions, time the execution of a statement, print the execution history, the ability to orchestrate workloads at a very basic, notebooks at a very basic level by using %run to run another notebook. So I could kind of set up okay, do this one, then do this one, then do this one. There's some other things I can do with that. And then some of these, like if I wanted to render it as HTML, or if I want to configure the Spark session settings, this one actually has to be the first cell of the notebook, I believe. So within that %% configure cell, and this is why I was talking about the session configuration, so you can upload this as a text file, and that'll apply to the entire server, and everything by default will get that. Or I can override it per notebook, or per session is actually the way to phrase it better. And I have all these different options available to me to set different things. So I can say, if I need to use other Python scripts or other jars, how much memory should I allocate for the driver process? How many cores should I use for the driver process? How many for the executor? How many executors should I launch? So there's ways to control that. Okay, and I'll show you in the experience another way to set that as well. So you also can create widgets. This is kind of interesting. So this allows me to create little graphical UIs to provide input and to kind of parameterize your notebooks. With Synapse, it also supports the notion of a parameter cell where I can define parameters, and then if I want to use Azure Data Factory to pass parameters in, it uses that parameter cell to kind of marshal those values. This is a lot of kind of behind the scenes. This is kind of magic because these things don't actually, they exist to take the input, but when you see, if you ever look at how Spark submits a job, these widgets aren't, it doesn't understand these. It just understands the values that you get from being passed as like an environment, right? So, or input. So this is kind of some UI magic, right? That doesn't really exist to the Spark doesn't understand this. It just understands the values. But there is code in here. So basically what I have to do is I have to import the library and then instantiate the object and then do a display on the object, and that'll render the widget. And I've got things like sliders, checkboxes, numeric widgets, selection widgets, string widgets, right? So this is really useful. I use this a lot, especially in Databricks, to parameterize things. Like, so if I have a dev key vault connection or a dev database connection or anything that would change, or if I want to use one kind of basic notebook framework to dynamically process different files or process different tables, you could do all that through widgets or parameters. The Variable Explorer is pretty cool. So this is not something that is in Databricks. So this will, within Python only, I believe, will show you all the variables that are in scope and the values, right? Which is super useful because this can get confusing, because what's important to understand is that when I create or connect to the Synapse pool, an application is created and then a session is started on that. Okay, and the session is where all the scope of this code all lives. So it's possible for me to, in this cell, define a bunch of variables and reference them from a cell down below or another cell subsequently. And what can happen is if I'm doing a lot of development and kind of moving back and forth, I can get a notebook that doesn't run deterministically, because it might succeed if I run it manually, but if I run it from A to B to C, if certain variables it's dependent on that initial state and that scope. So being able to figure out what values variables are currently set and what the values are is hugely beneficial. Okay, so workflows, I can use this %run magic to set a path to a notebook, and here you can see I'm just passing parameters, right? So I've got string parameter, bool, float, int. So that's incredibly useful to do lightweight orchestration. You can also use Azure Data Factory, so we'll look at that. The Microsoft Spark utilities. So this is, Databricks has a similar concept, but this is a whole set of libraries to help you kind of work with the Synapse environment, just like the Databricks utilities help you work with the Databricks utility. So I can actually call it via code here instead of the magic using the notebook.run. And then this is hugely important too, is I can call mssparkutilities.notebook.exit and set that to a value. So if I run a notebook, right, I'm not necessarily going to get rich error information back from it, or I may want to return data back from the notebook. This is a way to do that. So what I kind of do in my kind of larger projects is I'll create a string, maybe with like logging information or a complex return, like multiple things I want to return, and send that back as JSON as a string. And then whoever's returning that, whether it's Azure Data Factory, or if it's Airflow or something else, they can grab that string, treat it as JSON, and then process it. And that way I'm not limited, because here you can see I can just pass like a single value. If I use something like JSON, it can be very complex, right? It can have nested arrays, nested objects. You can get as complex as you want. So that's a good thing to do, is to call this notebook.exit from the last cell in your notebook with a value, so that gets turned back to the caller. A lot of times people are doing notebooks exploratively or kind of ad hoc, but sometimes those things get actually turned into production. So we'll talk about that in a little bit too. So again, just different supports within the same notebook by using the magic commands. So here I'm using 3 different languages. And then I can also do pipeline orchestration in ADF, and I think I'll pull this up in the UI for you guys here in a second. One other thing to understand is I can also run these by using the Spark and Hive tools, which isn't greatly named, but if I have Python installed locally, a Python environment, that can be a virtual environment, and I install these utilities in VS Code, then I can use this special magic syntax, this %%, and it's going to run this. It's going to connect to a Spark pool. It's going to create an execution context, and it's going to run this interactively. So some people prefer more of a rich IDE, right, that's not web-based, so this is that option to do that. There's a similar support for Eclipse if you come from that side of the ecosystem, but I like using Visual Studio Code. So with that being said, let's take a quick look through some of this orchestration. So now, in order to get to Synapse, I have what's called the Synapse Studio, so I can open that, and that's just web.synapse.net, and I can browse to that, and I can switch between different workspaces here, but this should look really familiar if you've ever worked with ADF or Synapse, right? So the only thing here that's, I wouldn't say is different, but what's specific to the Spark environment is I can create notebooks, and you can see here I've tried to organize some stuff with folders, and you can see I've got some basic demos, which we'll get to in a second. But basically, like if I'm going to run, let's just take a look at this one. This one's kind of simple. So this is an example of a markdown cell. These are really good for putting like documentation and probably spelling stuff, right, too, is always a good thing. So let's just fix that. So you can see what I did there. I just clicked on the pencil to edit it and save it. And now notice there's this little dot here. I'm connected to source control, so it's going to give me the option to commit this. So this will save it, and now the dot goes away. I can also do what's called a publish, which will actually push this into the live or execution slot, right? So right now, this is kind of like a pseudo dev environment. You'll notice here that it remembered that the last time I ran this, it connected to this workspace, but now you can see the second pool. So I can choose which pool I want to connect to, and then I can choose my default language. Let's see what we have. Now, if I run it, what's going to happen is it's going to take a few minutes, so I'm going to talk through this, but basically it's got to spin up that pool. So this is showing you that it's truly a serverless technology, right? There's resources in Azure that are kind of waiting to be assigned to this, but I didn't turn on a cluster, right? And in fact, if I want to turn this off, if I go back to here, and this was super confusing, I want to look at these pools. Oh, that's the wrong one. Doesn't really matter. And even there's no way to turn it off, right? I have pause settings, right? But if I click on that, that's just the enabling of the pausing. So if I wanted to stop this thing or start it, I can't do that from here. And then if you say, well, maybe if I go in from the Manage Hub and look at the Spark pool that way, right? So this is where I can look at the Spark pool and see the size and all that. But there's no option, and nothing indeed even tells me that it's running here, right? So if I want to see what it's doing, I can go to the Monitor Hub, and you can see I've got the notebook requests that have been running, and if I want to look at my pools, I can see my pools here, but there's nowhere here that lets me stop it or start it, right? I just see that they're there. I feel like this should be returning values, and it's not, and not really sure why that. I've noticed that a couple times. I'm not really sure why that is. So anyway, holy buckets, where did I go? I went to the wrong window. Notebooks. Okay, so it's still trying to spin up. We'll let it do its thing. I want to call out a couple important things to understand to save yourself a ton of frustration and money. This button is hugely important. What this does is once the session started, it allows me to stop it. The notebook will just run. There's a timeout session that I can set for the notebook itself, but it'll just continue to run. And then, so let's say I execute this, and then I say, oh, wait a minute, I want to go execute another notebook. And I start that notebook, and I connect it to the same cluster. It won't have any, it might not have any CPU nodes to run on. So I've got to come back and actually kill this application once it starts. And this is all, you'll see me, I'll go through some of these demos. I won't run it just because this is kind of what you see, right? It takes a while for things to start up, and you got to manage it, and it becomes kind of a pain in the neck. But once it's running, it's usually a little bit better behaved. So that's that one. The other thing that's important to understand is I talked about this is some session configuration information, packages, if I wanted to upload a custom set of packages. And here I can set different things about this, right? Now it's actually running, so that's good news. And it didn't find the demo database, which is probably because I didn't create it. But I could just do a create database. And this is actually using Spark SQL, which is why I didn't need a magic command there. An interesting difference between this and Databricks is, let's try this again. Comment this out. In Databricks, I could actually, and then hit right click and say run selection, right? I can't do that here, which is a major pain in the butt, I think. So you can see here it's going to show the databases. This is kind of cool, so it allows you to filter. So anything that's like demo star, I don't have any. I can do the same thing. Important concept to understand, schemas and databases are the equivalent concepts in Spark SQL. So there's no four-part naming. It's more similar to kind of Oracle, older Oracle, because Oracle now has contained databases. Here's probably the code that I should have ran first, is to create this demo database. What's cool is I can add comments to it, right? And I can actually set properties on there, which are just name value pairs, right? That I then can, once this runs, okay, that ran, and now if I run this describe extended on demo, let's see what we get. Should give me, there's my properties, right? It gives me the owner, storage location, where it lives, right? All that stuff, and I can probably make that bigger so you can see it. It is important to understand a little bit about this file pathing. We'll talk about that in a second too. So that's the notebook environment. I'm not going to dive too much further into kind of the mechanics of it. I do want to show you kind of what the Synapse pipeline experience looks like. It's this one. Okay, so here I've just got two different notebook activities, and it's pretty basic. I do this because I want to call something out that's a little frustrating. So I can choose a Spark pool here, right? And that's all good. And I can send in parameters and make those dynamic. But what I can't do is I can't make this notebook dynamic, right? So if I need to call 3 different notebooks, I've got to have 3 different tasks. Normally in ADF, what I can do is I can parameterize these things. Now, I can solve that in a couple different ways, right? I can create a notebook that's very generic and takes parameters to do different behavior. Or I can create one kind of orchestration notebook that does all the different steps that I need to do and just have one activity here. Or I can do, and we're not going to get into the job demo, or I could do the Spark job definition, or have a little bit more flexibility in terms of what I send in for the command line environments, right? But you can see here I can't make this dynamic, whereas here I've got add dynamic content, which allows me to make that data driven. So I just want to call that out just briefly. Let's get back to the demo here, or the slide deck. All right. So the most important takeaway, especially if you haven't worked with this, is to kind of understand how to put all this stuff together, right? So generally speaking, if I need to do some kind of data pipeline, I'll start with a Synapse pipeline, or I can use an Azure Data Factory pipeline to move data into a data lake. So let's say I want to copy data from an on-prem SQL server into the data lake. So I can use the Synapse pipeline to do that. I could very well do that via notebook, but that doesn't make a lot of sense in this case, right? The notebook can kind of come in, and I can use the Spark pool when I need to transform or implement ETL transformations, any kind of cleansings, reprojections, changing structure, converting something. Let's say I get data from an FTP server that's in a JSON format. I want to convert that to a more tabular format, maybe like a Parquet format. I can do that all with the Spark pool. And then what I can't do with the Spark pool is I can't run ad hoc queries from a reporting tool, right? That's not supported. So Databricks has that capability. I'm not a huge fan of that. But what I can do is, because the serverless pool and the Spark pool share some of the same metadata, I can do my processing in Spark, and then those tables and views can be exposed to the serverless pool. And the serverless pool I can run Transact SQL against, and query it. So this is a really good architecture to use these two pool types together. So I can do some transformation with serverless pools, but Spark's going to give me a lot more robustness in terms of supporting data sets, a lot more control over the scalability. With serverless pools, it's all done kind of behind the scenes for me. I can't control how many nodes, how much memory I'm using. I don't have a lot of insight into the query plans and stuff like that. So right now, Spark Pool is a much better choice for doing kind of large ETL type stuff. So key takeaway, Synapse pipelines for data movement, where I'm just primarily moving data from A to B, Spark pipelines for transformation and enriching, and serverless pools or dedicated pools for querying. Okay. A little bit more about the Metastore. So there's some limitations here. I have to create what's called managed tables, and the databases that I create are all viewable from serverless. It's going to add this DBO schema in here, but you can see this actually should be DemoDB, but it'd be DemoDB, right, demo Parquet. So I create the table, I can do transformation on it, I can create it based on existing data that I have, so on a bunch of Parquet files, and then I can query it from my serverless pool. One thing that's important to understand when we start talking about doing this type of architecture for real is to come up with a good storage structure for your data lake. So this is, ignore this CDF stuff, but basically the medallion architecture is kind of what Databricks is proposing. So you do bronze for your raw data, kind of as is, and silver for lightly transformed, and gold for like cleansed and enriched and business level data. And they would probably recommend that you use Delta Lake for the structure behind all these for the most part. I tend to think this is a little bit overly simplistic and kind of more marketing architecture. So I do something that's a little bit more separated out into specific purpose-driven zones that make sense to me. So raw is data that's untouched. Structured is when I take raw data that isn't in a tabular format and make it more tabular format, and maybe sharpen some of the data types. So do some converting and remove some data that's not needed. Stage is where I'm going to dump intermediate data that comes in. It's been processed, it's been cooked, and now it's ready to be ingested into another system. So this is kind of a transient layer. Temp is just kind of if I need to have multiple stages or paths. So these two are both transient layers. And then curated, if I want to do a data lakehouse architecture or a dimensional model that lives inside of a data lake, that's where I can have my curated zone. Ref is kind of a special purpose of raw where I let users actually upload files to there. These are files that don't change very frequently, so infrequently changing files tends to be smaller and tends to be more data that the business manages. So you can think of maybe your master data or your lookup, your decodes, those kind of things. And then archive to move data out, and a landing zone to basically keep data that you want. Somebody's going to FTP data to you, so you want to give them a place to push it, and you want to pull it rather than to give them rights to your data lake, right? So you don't need all these zones in all architectures, but just giving you some thought about how to structure this. And then obviously you're going to use additional folders within each zone to further segment out the data. So like for tables, I would have a raw zone, the name of the system, right? And then the schema as a folder, the database name as a folder, and then within that, the tables. And then I partition it, by date. We'll look at that a little bit more. So again, just some more stuff on databases, creating tables. So with Spark SQL, I can create tables, right? And I can create tables from Python as well. Unmanaged tables. So notice here, what I'm doing is I'm creating a table, and it's going to say use CSV as the underlying output format. And then as I insert data into this or add data to this, it gets written out to these CSV files. Whereas in this case, I'm mapping it to data that already exists, tables that already exist. And I'm saying basically it's a Parquet file that lives at this location, and we're going to call it demodb.external table. Key thing here is when the table is dropped, the data remains, whereas here, when the table is dropped, the data is dropped as well. So something to keep in mind between managed and unmanaged tables. Temp tables temp views are pretty commonly used. It's a good way to just kind of abstract away the underlying file format here. So this is a CSV. I can put all my options against this, and then I can treat this just like the CSV file, basically just like a table. And I can specify caching options, and I can do a ton of other things. It's the scope to the session. So if I create this temporary view, not only can I use it in that same session in another cell, but I can actually use it from a different language. So and I'll show you an example of that where I create a data frame in Python and then call it from SQL and then call it again from Python. So I can switch in and out of those different programming languages. Some things are very easy to do in SQL and look very cumbersome in data frames, but generally speaking, between SQL and data frames, you have the same ability to do different languages. So data sources, you have text, right? CSV, JSON. It's important to understand you have single and multi-line data, JSON types. So some JSON has all the data for an object in a single line, and this should be treated as 3 different rows, whereas this is an array of multiple lines. This is just going to determine, knowing your JSON type is going to determine the strategy of how you are able to process it. So it's just important to understand that. So you would specify a different option when you're working with single line versus multi-line when you read JSON. Parquet is a columnar storage format, very similar to clustered column store. So it compresses the data in columns as opposed to rows. And this is 9 times out of 10, you want to use Parquet or potentially Delta Lake to store your data in. This is going to compress it, optimize it for queries. I kind of skip over that for time. Delta Lake is kind of the new thing. The problem with Parquet is that if I need to make updates to Parquet, my option is to really rewrite the entire file, right? Load the file that I have, make my changes in memory, and rewrite out the whole thing or write out a change set, right? With Delta Lake, I can actually do CRUD operations. So I can do merges, I can do inserts, updates, deletes. It also supports time travel and transactions at a table level. So I can commit multiple actions to the same table as a single transaction. What I can't do, at least last time I checked, is I can't have table A and table B participate in the transaction. That's not a thing. It's just ACID transactions for the table. And then time travel to where I can say, show me what this data looked like as of this point of time, right? So it maintains it's basically a Parquet file under the hood with the transaction log. And then you have the ability to truncate that transaction log and clean it, which limits your ability to use time travel. But the downside of not cleaning your transaction log or your history is basically the file just gets huge and huge as more data changes over time. Okay, and it supports schema evolution or schema drift, so that's cool as well. So just some different kind of breakdowns of these different file types. And I want to show kind of a demo around this real quick. So it's important to understand, like, how do I reference the data that's in the data lake, right? So you saw some of the examples just use kind of a standard Linux pathing. If the data is in an ADLS storage container, that's your primary storage. So when you define the Synapse workspace, you designate one storage count as a primary, then it's going to use pass-through security. So it's going to use the identity of the Synapse workspace to do the security, and you don't need to mess with it. It just works. But you need to use this Azure Blob file system. So storage account has what's called a container, and then the account is the account name of the storage, and then it's dfs.core.windows.net, and then the file path, right? And that can support. So that just works out of the box. But you can also set it up so that, for example, here, I want to connect to, I've defined a link service in my, integration pipelines use link services that's connected to a Gen 2 storage account, and it uses a SAS token. So I just basically specify this Spark config value, give it the link service name, right? So I can share those artifacts between Spark integration pipelines or Synapse pipelines. I tell it it's using a SAS token, right? And then I need to make sure that I use link service-based SAS provider as my token library. And then it just knows basically that, hey, go look for this link service to reference this container, okay? If I want to use a managed identity or service principal, it's very similar. It's just a different token provider here. And notice I'm not specifying the auth type. I'm just giving a provider type, link service name, and then a path. And it's basically able to work out based on this path the right credentials to send through, okay? And then if you don't use link services, oh shoot, this is not right. Sorry, this is copied slide. There is a way to do it without link services, basically, and I can look it up from Key Vault or I can hard code it. It basically relies on it. There's another config value. I can't remember what it is off the top of my head, but I put another conf entry in here and I put in the SAS token or key. The problem with that is you don't want to store that. That's not something you want stored in code. So the other way to do it is to look it up from Key Vault, which is more secure, but I double copied that. I'm just going to, kind of just in the interest of time, I'm going to look through some demos and we'll talk through kind of some more basic stuff. So let's take a look at working with data sources. So this is an example here, and this is in Spark SQL. So you can see here, all I'm doing is just a select from this text file, and I'm using this is a backtick, so it's important to understand that, and it's just giving that path, right? Now what's interesting about this is it'll run, and this might actually throw an error, we'll see what happens. Yeah, so you'll see this is exactly what I was talking about. So what happened here is it says, hey, you requested 12 vCores, which is basically those 3 times 4 cores is 12, right? So the 3 nodes. However, the pool only has 0, so something's running, right? So therefore, I can't run this. So what do I do here? Well, I know because we were just looking at this. I have this notebook, and you notice now this is active because it's running. And in fact, how I can check for this is if I go to Monitor, and I go to Apache Spark Applications. Why isn't that showing up? Spark pools, hang on. Here we go. So this active applications shows me that something's running right now, and it's actually this notebook, right? So that matches the notebook name, and here's the culprit. So what we've got to do is we have to terminate that. And so to do that, I got to go back over here and hit the stop button. And so that'll stop the session. So any data that's in memory here that hasn't been written out will disappear. But these database definitions will live on. Now that the session stopped, and I'm going to close this so I don't do that again. Now if I run this, it'll be able to start the session because I freed up those resources. Now that quota message might look like a core quota on your Azure subscription, but it has nothing to do with that. It has to do with the cores on that cluster. Now, the other way to solve that would have been to choose my other pool and run it on the other pool. I don't like that because I feel like if I needed to run 10 or 15 notebooks at the same time, I'd have to create 10 or 15 different cluster definitions. So that isn't super optimal. So what's interesting here is you'll notice that I have 2 examples here that I could potentially run. I'm specifying CSV dot, so that's telling it what type of file to read it as, and then giving it a path. What's important to understand, though, is if we go to Storage Explorer, you'll notice that that blob storage path is the demo container, which is right here, right? And then it's people.txt, which is this file right here, and that'll read, right? And that's going to still process in the background. But when I designate this as a primary storage account, it creates a Synapse folder, and you'll notice that it has a bunch of stuff that it maintains. So you can think of these as kind of like system tables and stuff like that. And it'll actually store tables, table definitions. So all my tables that I create in the pool are actually stored here. But also, if I give it that path by default, it'll just put it in the root of here. So what's happening there is it's saying basically select star from this CSV, and if I don't give it a path, it's going to point it to that location of your cluster. So I don't think that's a best practice to do that. I like to create explicit containers for all my stuff. So for demo purposes, this is fine. I actually manually uploaded this file here, but if I create a data frame and dump it out to a table or something, don't give it a location, it's going to put it right here. And that's not what I want to do. So I want to give it a good location. So you can see it queried that. Now the problem here, well, is this file actually didn't have any column headers, so it just gave it column 0 and column 1. It's just 3 rows, right? Pretty simple. And this will do the exact same thing because the files are the same. Now, it's not going to take as long as the other one did, but it's still going to take a little bit of time. So it's important to understand this is still very much a batch execution environment. It's not interactive like SQL, which is why I recommend using serverless pools or dedicated pools or some type of a SQL for user-facing query workloads. Now, I can also use that same path and create that as a temporary view and then run a select from it. right? So same kind of concept. But notice what I can do here is I can actually put in, if it did have a header, I could put header equals true, whereas I lose that functionality with the direct SQL, right? Just calling CSV, there's no way to specify that, where I can do that here. And I can choose a custom separator, and all the options I might need to set with the CSV are done in this options thing. So that's something I uniquely can do with views here. JSON, it's the same story, right? So I can call a JSON file, creating a temporary view, just passing this path. Parquet, same kind of concept. Now what's interesting about this Parquet file is notice this element right here. This is actually a complex type, and what this is an array, right? So when I do a select star from here, it gave me 3 columns, but this has other data, right? In SQL, we would use an outer apply or cross apply to break this data out, right? Potentially, or pivot it out. In Spark SQL, we use what's called a lateral view. Or we can use explode is the way to do it in PySpark. So again, I can work with my Python things. I can create my Parquet files using that mechanism, or I can do it from, this is PySpark, right? So because the default language is Spark SQL, I have to specify the language. I'm going to create a data frame, and I'm going to do spark.read.parquet. I could also do CSV. In fact, check this out. There's nothing to prevent you from being stupid. Except when you have a typo in your demo. Let's delete that. I think that still works. So it's going to try to use the CSV driver, and it's going to try to load the Parquet file, which is binary, and try to load it into some kind of a tabular CSV type format. So make sure that not only are you using the right extension here, right, the right reader, but also that if it's a .parquet file, it's truly a .parquet file. Somebody could have uploaded this and called it, just renamed it to Parquet. Could have been a text file, right? So if I start seeing weird errors from the Parquet driver, I make sure I validate that file, because it's a binary file. You have no idea what's in it without opening it up and looking at it, right? So Delta Lake, we're kind of running a little short on time, so I'm going to skip over this, but it's very similar, right? You can see here, everything comes from a data frame, and then writing it out or reading it, and then here I can use format delta, or I could use read.delta, right, and load it, those kind of things. So we're kind of at time. I know we started a little late. There was one thing I want to show you guys real quick, is when you start building these notebooks, it tends to turn into just a hot mess of just flat structure. Put a structure around it. So here you can see I've got a notebook structure. I've created a template notebook, right, that I can use as a starting point. I've separated this out into an extract phase, transform phase, load phase. I've got includes for common business logic, right? So I might have some includes for data access, logging, and utility functions. I can just call those with a run function from the other notebook, and that'll bring all those methods and functions into scope. And then an orchestration folder. So I have a main, and then I have a main for extract, main for transform, main for load. And this just is a nice clean structure to kind of work with. And this is all cleared out in my slides. But so say I was bringing data from AdventureWorks, this would be, AdventureWorks, and then this would be AdventureWorks sales and AdventureWorks customer, and so on. So one notebook per table, or if I can create a generic notebook for all the tables, even better, right? But just organize your notebooks. Don't build like a huge single monolithic notebook with hundreds and hundreds of cells. Make smaller kind of purpose-driven notebooks. Okay, so with that, let's just go back to slideshow and wrap it up real quick. Just real briefly, I can create an environment specification with all the libraries that I need and save it out as an environment.yaml and load that up to make sure it always has the same environments. That's a Python thing. I can create my own custom modules in Python and load those up in. So here I'm using a tool called Poetry to generate a module. So it does all the kind of busy work of module creation. I can then use the Poetry and import that as a wheel file, which is a Python module. I can load that up to my storage account. So I can load it. I can make that part of my CI/CD process. Unit testing. So there's PyTest to do unit tests if I need to unit test. just an overview of the refactoring and unit test cycle. Great Expectations and Deque are two different data quality libraries. So a big thing with this data, since it's text-based and semi-structured, is there can be data quality problems that you're not aware of. So kind of using these libraries to assess the quality of your data is hugely important. I can set up alerting and logging to log analytics from Synapse. So that is all part of the Spark configuration. And then I can actually use the Log4j, it's kind of timely, logger from within PySpark to log custom messages out to that log, and I can see them all in one place, right? So you don't have to roll your own logging with the database code or anything like that. I can consume all this via Kusto and Log Analytics, which is super handy. And DevOps, there's a workspace deployment task. So, all of these are probably topics for a whole session. But just understand that Azure has many ways to run Spark workloads. Benefit of Synapse is really all about a single unified experience, right? So if you're already using Databricks, that doesn't mean you move everything from Databricks to Synapse. There's no reason you can't use Databricks with Synapse serverless pools or other combinations of the technology. But if you don't have any Databricks and you're using a bunch of the Synapse technologies, maybe that's a good place to start. You want to structure your code to make it very modular and use functions and modules, especially when you get larger kind of data engineering pipelines, and making sure you're picking the right formats for the underlying data lake and the right structure to make it user-friendly. So with that, sorry for going late, but if there's any questions, feel free to ask them now.
Great stuff. Thank you very much for that. Yep. Jason.
Yeah, that was a brain full of things.
Yeah,
so
a lot of stuff.
We though have a couple of questions. Do you want to do the first one, Mark?
Okay. Yeah, so one of the reasons I understand that can be argued for the use of Databricks over Spark pools is that the Spark version may lag behind the current released version. Do you see this as a real problem or just a minor consideration?
It's not a problem until it is, right? So I think it could be I've run into this a couple different times. So it seems to me that the Synapse team is definitely behind pretty significantly in terms of where they're at with Spark. So they're on 3.1, right? And I was actually going to show this. So here's the documentation with all the SQL functions and stuff is all here in this spark.org docs latest, and they talks about working with data sources. We see they're already on 3.2.1, right? And this is going to continue to rev. So if you for whatever reason you take a dependency and you need cutting edge functionality, you're stuck with Synapse, right? Whereas Databricks, you're still stuck, but they generally tend to push stuff out pretty quickly, right? So it's a consideration. That being said, as Spark gets more mature, it's less of an issue. And again, Databricks has more versions to choose from, right? So I've been in a situation where I've actually had to downgrade Databricks clusters because I ran into some weird dependency where a Python module that I was using didn't work with a certain version of Spark, or it's such a complex environment. So my other advice is to not use this unless you really need to, right? So you're dealing with really large data volume, or you have that complex variety of data. Because when you get into, especially with third-party modules and stuff, you can get into these weird dependency, kind of like DLL hell that we used to run into with Windows NT and 95. And it can be almost impossible to figure out what the heck's going on. So it's definitely a concern, but if you're sticking to very basic stuff, you shouldn't encounter it, right? Like I would say 80 to 90% of the stuff that you're going to do, it's not going to matter much, right? You might miss out on some performance or some newer features of Delta Lake. But if you do get something that's pretty complex, or you're using a lot of third-party libraries that are built with specific versions of Spark, you could get yourself into a corner pretty quick.
Yeah, I mean, since we've got Bob Duffy, who's desperate for everyone to use Databricks, it's probably worth me also saying that someone in Microsoft has suggested to me they may start ramping up their release cycle for the Spark version, but what that means is anyone's guess again.
Right.
So we have consolidated a few questions because we have received the answers, but not nuanced enough on those.
Okay.
So this is a sequence of questions that you can answer with yes or no in the end.
Okay.
Probably not, but anyway.
I like it.
Are notebooks always interactive, or can you use them to run transformation and store the results? If yes, where can we store the results? In data lakes, delta lakes, Synapse tables, in SQL pools? And can you share the data or databases between pools, between SQL or Spark, or between Spark pools or SQL dedicated pools?
Yeah, so that's a good question, and let's just real quick, let's go back to this. Won't exactly tee it up, but it'll give me something to point mouse at, right? So basically what happens is notebooks are primarily an interactive experience, but I can run those notebooks via a couple different mechanisms, right? There's an API I can call, which I wouldn't recommend, but you might have to do that. I can also use the Synapse pipeline activity to call that notebook, right? I remember I showed you guys that. And so the notebook then, what it would do is the primary pattern is about reading data in, manipulating that data or transforming it. And it could just be you're changing the structure. Like I'm getting the data in XML and I want to write it out to CSV, or I want to write it out to Parquet. So the notebook would read the data, do the transformations, write the data back out, right? Potentially to a Delta Lake table, or potentially to a Parquet file, or to a database. It could be a dedicated pool. It could be an Azure SQL DB. It could write it out to Cosmos. So generally speaking, those readers and writers are bidirectional. So anything I can read from, I can write to, right? Anything with a JDBC driver, I can read data from and write data to through that JDBC interface. And there's other built in, like what's really built in is Parquet, Delta Lake, CSV, XML, the basic file formats. And then generally speaking, what you do is you write it back out to the data lake, and then your next step would be to move it from the data lake into its final home. But you don't have to do that, right? It really depends on what you're trying to use the data lake for and how you use it. So there's nothing to stop you from creating a notebook that reads data from Azure SQL DB and writes it back out to Azure SQL DB to a table, right? So I could do that, or I could transform that data and write it out to a Delta Lake table, and then I could read the Delta Lake table from, well, unfortunately I can't do it from Synapse because Synapse Pipeline Delta support is only for Databricks, so that's something that's worth calling out. But I like this pattern of if you're going to do a logical data warehouse, or if let's say you're just using analysis services, Tabular or Power BI, if that's your primary consumption mechanism, and you need to process complex data, do that processing in your Spark pool, write them out to external tables, and put your tabular model to the serverless pool. It'll query the serverless pool and bring the data in for you with Transact SQL. So you're familiar with that language. It's very, you don't have to learn anything, right? You use what you already know. But the serverless pool behind the scenes is querying either Delta Lake files or Parquet files or CSV files. So the answer to those is you can do all those kind of things. You can mix and match it and build out the architecture that makes the most sense for your data volume, your latency, and managing the costs. The benefit of storing in the data lake is it's orders of magnitude cheaper to keep it in the data lake than it is to put it inside of a database service like a dedicated pool or an Azure SQL DB, right? But the trade-off is the performance isn't going to be as real-time like we saw that. There's a little latency involved in accessing those tables. So hopefully I unpacked all those questions.
Yes, perfect.
Okay.
Cool. So we go to the final question, which we've flagged as being the Smarty Pants question. And this is where you are either going to impress us immensely or fail. Okay, so do you know if there are any limitations when using a Spark pool as attached compute for Azure Machine Learning Service? And incidentally, I've had a quick play, but the experience seems a little flaky, though the feature is currently in preview.
So I know just a very little about that. So the machine learning services has their own compute, and that's probably going to be more reliable than trying to call out to Synapse. And that would be a situation traditionally where I'd recommend Databricks, just because Databricks traditionally has been better with the machine learning support. So yeah, I don't know specifically like what the limitations are, but if I was using Azure Machine Learning, where Synapse Spark pools are right now, I would either use the compute inside the Azure Machine Learning, or I would use Databricks, right? Now, that being said, right, there's two distinct phases of machine learning, right? There's training the model, right? And then there's publishing the model, right? So Synapse cannot host a model, right? Dedicated pools can host a model. So if I can train a model in machine learning, I can actually host that model. I can dump it out to an ONNX file format, and then I can publish it inside a serverless pool and use that model and run it across my SQL data without needing a web service call, right? So training the model, probably today best to be done on Databricks, could be done on Spark Pool, probably not the best to integrate it with machine learning services right now. I would definitely expect there to be some flakiness.
Perfect. I think we'll pass
Right.
him with that one, Miguel, don't you think?
Yeah.
All
And
right.
as you said, Mark, that would be the last question. So thanks to everybody for joining us, and a very big thanks to Jason.
Thanks, guys. Good seeing everyone, and take care. And feel free to connect to me on LinkedIn or reach out if there's any other questions or things I can clarify further. I know we went through this a ton, and there's a lot of material to cover, so it's a tough session because there's so many different aspects of it.